Hey everyone, welcome to part 2 of my girder build series. This episode is all about making the legs. Okay, so my original design goal was something like this, using straight 1.5 inch tubing on the front, with the rear being made from bending 1 inch tube. I even got the front tubes cut to length and shaped to fit the ends before realizing I didn't like how the larger diameter mated with the smaller ends that I had already made. Since those tube ends were pretty involved to machine, I decided it was easier to go back to the drawing board and go with this symmetrical diamond leg design that keeps all the components at 1 inch diameter so it'll all fit better together, and honestly I ended up liking it more anyway. So the first thing I did was measure the distance between the rear pivot points so that I could fab up this little jig to hold the leg pivots at the exact same distance, because it's really important that all of those pivot points are equal in the end. So with that secured, the next step was to figure out how much trail I want, because that will determine how long to make the legs. There's a few factors I had to consider for the trail: the wheel diameter, which in this case is 21 inches, the rake angle that I'm keeping at 35 degrees, which is the stock geometry for the Shadow 600 frame that I'm starting with. Then you can see here I just marked on the ground enough trail for stable handling, and when I lined up the wheel with that, it was just a matter of measuring from top to bottom, and that gave me roughly how long I needed my legs to be. And with that, I cut my legs just a little bit long, and I started to bend them up with my JD Squared Model 3 tube bender here. I love this bender. I use it all the time for frame and exhaust making. So to get these bends, I just marked down 10.5 inches from the top of the tube, and I made that the peak of my bend. I went with an 11-degree bend, and there's really no right or wrong angle for these. They just need to be wide enough to fit that cross brace in with the lower pivot eventually. After I got all my bends nicely uniform, I had to calculate the specific angle to cut the tubes so that they'll fit tightly together, which is important to get the strongest welds. Now this part's kind of hard to explain, but I had a choice with these cuts to make either both tubes equally angled so that they would mate together symmetrically like a V, or what I ended up doing, which is to cut only one tube and have it sort of wrap around the other uncut tube. Since I don't have any fancy tools for calculating the degrees, I just used this mini right angle, and with some very delicate eyeballing, I came up with a 15-degree angle on the bottom of the legs, and with the help of this adjustable angle finder, I came up with 21 degrees for the top side cut. I got my Bailey tube cutter out for this, but even the 21-degree angle was so steep, I ended up having to hand finish the cut with my angle grinder. Okay, so here I'm test fitting my 21-degree cut and getting mentally prepared for the 15-degree angle that the hole saw couldn't get more than like a quarter of the way through. I'll be honest, this was some really tedious cutting and shaping to get the fitment nice and tight and uniform so that both legs would end up being perfectly symmetrical. Okay, with all those angles rough cut, I took a minute to get the tubes cleaned up, just to start prepping for welding, and because it brings me joy to work with clean metals. So here they are after some Scotch-Brite and WD-40. Then came the tedious process of dialing in those angle cuts, because it's really important that the leg pieces fit together tightly for welding, and that both the left and the right pair share the same final dimensions. The way I ensured all of that was by stacking the assembled legs on my table, and using welding squares I could sight down the length of the tubes and make corrections to the ends until I couldn't see any light between the legs and the welding squares. This took so many passes, and I probably fiddled with it way past the point of diminishing returns, but regardless, when I felt done with it, as you can see here, the tubes follow the same lines, and I feel like they're as close as I can get them. And that means it's time to clamp them down and start welding. Okay, now with those welded up, I needed to cut the ends to fit my pivot and axle tubes. I tried doing this in my drill press, but I couldn't get the leg clamped down well enough. You. So I ended up just marking the tube ends and grinding them into shape, which, like much of this project, was pretty tedious. Finally, I got them all hugging the end tubes nice and tight. And to make sure I welded the ends perfectly centered on the legs, I made some shims that raised the legs to exactly where I wanted to meet the end tube. Then I just clamped the legs down and bolted the ends to the table in hopes of welding them with minimal warpage. But as I've learned, there's no stronger force in the universe than the movement of metal being heated and cooled. So after welding these, I found that the bearings and axle were not wanting to fit well anymore. Thankfully, it was such a slight movement that with a light hone using a tightly fitting 220 grit barrel sander, I was able to get back to a happy slip fit of the parts. With one tube done, the challenge I had here was to weld the second leg ends on so that both legs were exactly aligned with each other. Every thousandth out of true here would cause binding across the left and right legs once I assembled, and that increases wear on the bearings and thrust washers. So I ensured the tube's alignment by machining an inner tube that tightly fit inside my end pieces, hard locking them together so that they cannot irreversibly be warped by welding. Then I held my breath and welded the last legs on. And it worked. I did my first test mount here, and I was really happy with how it all fit up. The lower pivot was perfectly in line for me to get the cross brace in and weld it in place. To make the braces, I used 1/2 inch thick flat bar and used the aluminum jig to show me exactly how far down the leg it needed to fit. The next step was to bore a hole perfectly in the middle for the pivot tube. Since both braces need the hole in the same place, I lightly tack welded the braces together and then scored and center punched the middle. This way I can chuck them up in my lathe and drill through both at the same time. With the braces trued up using my 4-jaw independent chuck, I swapped this collet into the tailstock to mount one of these annular cutters. I can't say enough good things about these cutters. If you get a good set, they're so worth it. They cut clean, accurate, and efficient holes because they're rigid and remove less material. Spring for the carbide tipped ones if you can afford it. Now with the center punched out of these, the pivot tube fit in perfectly. Next it was time to get that cross brace welded into place. So I shimmed to get it perfectly centered between the tube legs, and as always, when you're making two things that need to be symmetrical, the first one's pretty easy, and then, well, the second one, that's the challenge. So here you can see how after I finished one of the legs, I stacked it on top of the other one, and with more careful shimming and a scrap bearing to lock the pivot tubes together, I got the second leg clamped down tight and welded it all together. Once I finished welding it, the spacers I made to keep the pivot tubes aligned did their job, but welding the cross brace warped the legs ever so slightly, so I had a bit of an arch across the leg now, top to bottom. And I really need that to be dead on so that everything is square and straight so it can move smoothly without binding. So the way I brought it back to square was I built this custom bottle jack brace that mounted to my welding table, and with that I was able to get the leverage I needed to put a controlled amount of downward pressure on the tubes. I worked in very small increments, pressing and checking until the legs sat dead flat on the welding table. Once I was happy with that, I gave them a second cleanup just for fun and went to go test fit them on the bike. I'll probably get a third hand to help me mount these in the future because with those pivot arms free to wiggle around, it was really tedious lining up the upper and lower points because they have to slide on squarely. But with some patience, I was able to do it myself, and once they were on, I was really impressed with how smooth and tight these things feel. So far, I think I'm on the right track. I also made a custom axle out of chromoly, which was a little tough to machine threads into, but I managed, and these nice brass acorn nuts fit up beautifully. As for what shock I'm going to use, I've experimented with several types, and I think this air shock is going to at least get me through to the rideable stage. The reason I chose the air shock is because it's highly adjustable and has a thin profile, so it'll fit nicely in the close tolerances I'm working with. Once I get it dialed in, I could calculate the spring rate and swap in a shock with a suitable spring if I can find one that fits, but honestly, I bet I'll stick with this one because it's a really really nice shock. Okay, so that's all I've got for this video, but stick around for part 3 where I'm going to tackle at least the lower shock mount and some sort of brake caliper situation and handlebars, which if you got any input on the handlebars, I'd love to hear it. I'm still in the planning stage on that. Haven't figured out what I'm going to do exactly. But either way, thanks for hanging out, and I'll see you next time.